So in today's lecture, we're going to talk about the confidence interval. What do we mean by confidence interval? Suppose I have this big bag of M&Ms. These M&Ms here, and I'm interested in knowing what proportion of M&Ms in this big bag are blue. This is the question that I want to answer. So let's see. What proportion of the candies are blue? Well, what is my approach here? What should I do? Should I start opening this big bag, which is very heavy? So we finally open this bag of all of these candies. I want to know what proportion of the candies in this jar are blue. So should I take all of these and start counting? Is it possible? How long does it take? How many candies are here? Probably 2,000 candies are here. It's a very big jar. So what statisticians do, they start taking random samples of specific size from this population. So first, take a sample, for example, of size n equals to 50. Count the number of blue candies in that sample. We need to call it X. So let us start. I need to take 50 candies and count how many blues are there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, and 50. So let me put this guy away. How many blue candies do I have here? How many? 2, 4, 6, 8, 10, 12, 14, 16, and 17. I have 17 blue candies in this sample. Okay, very well. So let me just put these away. In the next step, you need to find the point estimate. Now, find the point estimate. Well, what is a point estimate? A point estimate is an unbiased estimation for sample, for population using the sample. Since we are estimating the population proportion, this point estimate is the sample proportion. Okay, very well. Proportion. What is the notation for sample proportion? Sample proportion is denoted by p hat. So let us go back to elementary statistics and into the population. We are all left alone outside the jar. So, go back to elementary calculus. In elementary calculus, we learned that we have a population, am I right? We have a population. To that population, we can associate some numerical characteristics. Like what? Like the mean of the population, which is denoted by Greek letter mu, standard deviation of population, which is denoted by sigma, population proportion, which is denoted by p. And when we take a random sample out of this population, we have sample statistic. So for a sample statistic, we have the mean of that sample, which is denoted by X bar. The standard deviation of sample is denoted by S, and the sample proportion is denoted by P and a hat on top of it. So mean, standard deviation, and the proportion. P hat. So P hat, the sample proportion, is the best point estimate for population proportion. We need to find P hat. But what is the definition of P hat? P hat is defined as X divided by N. What is X? X is what we are looking for, the successes in our experiment. The success in our experiment, we're looking for blue candies, the candies that are blue. The success is how many blue candies do we have? So 17 is your X. Well, what about N? N is the sample size, which is 50. We usually write the proportion as either the decimal or the percentage. What is 17 divided by 50? By calculation, we have 34% or 0.34. So again, you have your big bag of candies, which is your population. We took a sample of size 50. We counted the number of blue candies in that sample, and it is 17. So we say that the sample proportion, which is our point estimate, is 34%. We do not say, hey, since one sample has 17 blue candies in it, so 34% of the sample has blue candies, it means that the population has 34% blue candies. We cannot do that. It's not accurate. What do we need? We need something that we call the confidence level. So in our next step, in constructing a confidence interval, after finding the point estimate, we find the confidence level. Very good. Now, we need the confidence level. So when we are talking about the confidence level, we are actually talking about the probability. The probability that the interval that you're constructing, that the interval contains the population parameter. Population parameter. That's the meaning of confidence level. So when it comes to confidence level, we have some confidence level that are very popular. C equals to 90% is one of them. The probability that the interval contains the population parameter be 90%. The probability that the interval contains the population parameter be 95%. The probability that the confidence interval, your interval that you're trying to build, contains the population parameter be 99%. These are the famous ones. But depending on the company that you're working with or the project you're working with, they might give you a different level of confidence. They might say, hey, we want that level of confidence to be 80%, 85%, or any other percentage or probability different from 90, 95, or 99. So we found the point estimate, which is your sample proportion. We find the confidence level. This confidence level is given in the question. Just a quick note. If the confidence level is not given in the question, always take 95%. So in majority of cases, your level of confidence is given. If it happens that the confidence level is not given to you, you use 95%. Okay, we found the point estimate, we found the confidence level. In the next step, we need to find ZC, or critical value. Critical value. Very well. Critical values are corresponded to the level of confidence. Critical values, or Z sub C, are Z-scores. Z-scores that we learned before.
Wait, Professor, I'm so sorry to interrupt you, but where did you get the 90, 95, and 99?
So critical value, Z sub C, is Z-score associated to confidence levels. To each confidence level, we assign a different Z-score or critical value. We're going to learn how to find the critical value for each of these confidence levels. So let us find ZC for confidence level 90%. So your confidence level is 90%, and we want to find the critical value for that 90%. So what's the meaning of this 90%? This 90% is the area below the graph. The graph of standardized normal distribution. So we have a normal distribution. We use Z to convert that into standard normal distribution. This is C, 90%, which is 90% of the area below the graph. 90%. Well, 90% of the area is just right here, am I right? 100% minus 90% is 10%. So 10% is the sum of these two areas to the left, to the right. So 5% is on the left, 5% is on the right. We have the area. We want to find the z-score. What is the z value? What is this number? We're going to use our calculator to find that z. Since you have the area and you want to find z, we're going to use inverse norm. Turn on your calculator. Go to second. Then vars and find inverse norm. So second, vars, find inverse norm, which is just right here. Enter. The area is 5%, so 0.05. The mean of the standard normal distribution is always 0. Its standard deviation is always 1. So area is 5%, mean is 0, and standard deviation is 1. Let us calculate the z. The z is negative 1.645. This is negative 1.645. But note that you have symmetry. This is 0. The opposite number is going to be on the right-hand side, which is 1.645. This guy is our ZC, or critical value. ZC, or critical value. We found the critical value for 90% level of confidence. So if the level of confidence is 90%, the critical value is always fixed, and it is 1.645. Very good. So we found the z-score, or critical value, for 90%. Let us write this guy down here, then move on to the next calculation. So 1.645. 1.645. Okay, I'm going to erase this part of the board and then try to find the critical value for 95%. Okay. ZC, or z-score. Let us find ZC for confidence level 95%. First of all, what's the meaning of 95%? 95% is the area below the graph. This is my graph. This is my 95%. 95% of the graph. Let us shade this. Okay. So 100% minus 95% is just 5%. So 5% is divided into half. Half of the area is on the left. The other half is on the right. So take a look at this. You already have 95% of the area. The rest, which is 5%, is divided up into these two little pieces here. So the area on the left is 0.05 divided by 2, which is 0.025. This is my area, this small area here. I want to know, what is this z value? What is this number? So I'm going to use my calculator. Second, vars inverse norm Okay, let me find this. Second, VAR's inverse norm. What is my area? Area is 0.025. 0.025. My mean is always 0 when it comes to standard normal distribution. Remember that since you are finding your z, it means that you are working with a standard normal distribution. Mean is 0 and standard deviation is 1. Mean is 0, standard deviation is 1. So let us calculate that. The z is negative 1.96. Negative 1.96. Because of symmetry, on the right-hand side, you have a positive 1.96, which is your critical value. This is my z. So the critical value for confidence level 95% is 1.96. 1.96. These are your critical values. So ZC. Now we want to find the critical value for 99%. Very good. So what about 99%? We are interested in finding the critical value for 99%. So what do we mean by that? We have 99% confidence level. What's the meaning of that? It means that the area below the graph is 99%. Am I right? So here we have 99%, which is pretty much all of your graph, 99%. The total area is 100%. 100% minus 99% is 1%. This 1% is divided up into two little pieces, to the left and to the right. This one is not 1%. If it's the 1%, this must be 1% as well. 1% plus 1% is 2%. 2% plus 99% is more than 100%, which is wrong. This 1% is divided into half. 1% divided by 2, well, it gives us 0.005. So this is the area on the left and the same area on the right. Very good. So I have a standard normal distribution. My mean is 0. Now I'm going to use my calculator. Go to second, VARs, and find inverse norm. Okay, so not that bad. Second, VARs, inverse norm. The area is 0.005. 0.005. The mean is 0. Standard deviation is 1. So let us just calculate that. The z-score on the left is negative 2.575 or 576. So on the right-hand side, of 0, we get positive numbers, 2.576. This is my ZC. So the critical value for 99% confidence level is 2.576. The next thing that you need to find is called the margin of error. So let me list these here next to each other. So in step one, we find the point estimate. which in our example, x divided by n was 34%. In step 2, we find the confidence level, CL. It's either 90% or 95% or 99%, depending on the question. Again, if it's not given to you, always assume it's 95%. In the third step, we find the ZC or critical value. So remember that based on our calculation, the critical value for 90% is 1.645, for 95%, 1.96, for 99%, 2.576. Well, in the fourth step, step 4, we need to find something that we call the margin of error. The margin of error, E, is equal to, after finding your critical value, you have to do a little bit of algebra. ZC multiplied by square root of P hat 1 minus P hat divided by N, and N is the sample size. Remember that in our example, the sample size that I used was 50. I took 50 candies from that jar. Very well. After finding the margin of error, we're going to find the confidence interval. The confidence interval is an open interval. The lower limit is P hat minus E. The upper limit is P hat plus E. So you can write this way. You can say that, hey, the population proportion is bounded between P hat minus E, P hat plus E. In your conclusion, you should write, we are, or I am, blank percent confident that P is within P hat minus E and P hat plus E. Okay, so let us take a look at our example. The proportion of candies are blue in that big jar. So we are just looking at our big jar of M&M candies. We want to know what proportion of candies here are blue. Remember that we took a sample of 50 candies and 17 candies were blue. X was 17. Then we divide them together to get 34% blue candies in the sample. In the next step, let us calculate the confidence interval for each of these cases. If the confidence level is 90%, then we know that ZC is 1.645. This is my critical value. What is the margin of error? The margin of error is ZC, which is 1.645, multiplied by this radical. Inside the radical, I have P hat, which is 34%, times 1 minus 34%, divided by all or inside the radical, divided by N. N is the sample size, which is 50. We have to do the calculation here. So let us take a look at our calculator. Turn on the calculator, clear. We have 1.645 multiplied by, well, here secant x squared gives you the radical. You have multiplication and division. use some grouping symbols like parentheses. 34% times parentheses 1 minus 34%, close the parenthesis, and divide by 50. Close the final parenthesis. Do the calculation. You get almost 11%. So 0.11 is our margin of error. 0.11. Okay, so we found the margin of error. In the final step, in step 5, we can calculate the confidence interval. Confidence interval says, hey, you have open interval p hat minus e. What is p hat? P hat is 34%. 0.34 minus 11%, comma, p hat, which is 34%, plus 11%. Well, my confidence interval is equal to 0.23% and 45%. So what's the meaning of that? It means that I am 90% confident that 90% confident that there are 23% to 45% blue candies in the jar, in the bag. So I expect to have 23% or 25% or 30%, 32%, 33%, 34%, 40%, 41%, 45%, or you can say that hey, almost half of the jar might have blue candies, or it might be just a third of this jar with blue candies. I am only 90% confident about that. So how do we calculate a very accurate confidence interval? How do I use technology to find a better confidence interval? Remember that we use rounding. We round ZC, we round the margin of error. So the confidence interval is not very accurate. You can use our calculator. To use your calculator and find an accurate confidence interval, follow the steps. First of all, go to stat, then go to tests, now you need to find one proportion Z interval. One proportion Z interval. Click on one proportion Z interval. Well, you need to find your X, you need to find your N. Well, we already did that. We already know that here we had 17 blue candies in a 50 candies sample. The level of confidence is 90%. So let us do the calculation. It gives us 0.2298 and 0.452. X is 17, N is 50. The confidence level is 90%, and the confidence interval is now 0.2298, and 0.4502. It is a more accurate confidence interval than the one that we calculated. So we expect the proportion of blue candies in the population be in between 22.98% and 45.2%. We are 90% confident about that. So let us repeat what we did for our blue candies when we changed the confidence interval to 95%. Very good. So we're going to repeat all of these steps and find the confidence interval. So now suppose you moved to the next confidence level. We calculated 90% confidence interval. Now we are interested in knowing what if I change the confidence level to 95%? What happens to my confidence interval? So if confidence level is 95%, we know that the z-score or critical value z sub c is 1.96. Okay. In the next step, we need to find the margin of error. E is equal to ZC square root of P hat 1 minus P hat divided by N. Well, okay, ZC is 1.96. Let's just plug them in here. Times the square root of P hat, which is my point estimate, is 34%. Parentheses, 1, 1, minus, minus, P hat, 0.34. Close the parenthesis, divided by, N is 50. Okay, let us use our calculator to approximate what is happening here. Turn on your calculator. 1.96 times second x squared. Since you have multiplication division, to make sure everything stays inside the radical, use grouping symbols like parentheses. I'm going to use two sets because I have multiplication and I have division. So I have 0.34 times, let me open a parenthesis for 1 minus 0.34, 1 minus 0.34. Let me close the parenthesis and then divide by 50. Divide by 50. Now close up the parenthesis that you have. You get an approximation which is almost 13%. Margin of error is 0.13. Okay, very well. What is the next step? I found the margin of error, and now CI, or my confidence interval, is equal to open parenthesis P hat minus E, comma P hat plus E. What is P hat? P hat is the point estimate, 34%. So confidence interval becomes 34% minus 13% and 34% plus 13%. So my confidence interval becomes, we do the subtraction, get 0.21 and 0.47. So our conclusion is the proportion of blue candies in this big jar is in between 21% to 47%. We are 95% confident about that. The proportion of blue candies in the jar is in between 21% to 47%. We are 95% confident about that. Well, I'm going to use the calculator to get a very better approximation for this confidence interval. It's always helpful to use technology. So calculator. Very well. To find the confidence interval for the proportion, we click on stat. So go to stat and then find tests. Let's go to tests. Then we need to find one proportion z interval. One proportion z interval. Step by step, click on that. Well, what is X? What is N? Remember that at the beginning, we took one sample of 50 candies. In that sample, 17 were blue. So X is 17 and N is 50. 17, 50. But now my level of confidence has changed to 95%, 0.95. Now let us do the calculation. We get very well 20.87 and 47.13%. This is my new confidence interval with better approximation. 0.20, 87, and 0.4713. It says, hey, we are 95% confident that in that big jar, we have between 20.87% to 47.13% blue candies. Of course, this interval is much more accurate than this interval. If you round this interval, we get to this interval, but this is much more accurate.
Okay, so I have a question for you.
Now let us move on to 99% confidence level. What if we have 99% confidence level? What is our confidence interval then? So if confidence level is now 99%, we know that we already calculated ZC. ZC is 2.576. 576, very well. I need to follow the steps. What is the point estimate? I already know that the point estimate is 34%. I have the critical value. I need to calculate the margin of error. Margin of error is ZC, which is 2.576 times square root of p hat, which is 34%, 0.34, parentheses, 1 minus 0.34, close the parenthesis, divide by n. N is the sample size, or 50. Let us take a look at our calculator and approximate the margin of error. So 2.576 multiplied by second. X squared gives you square root. Again, since you have multiplication and division, use grouping symbols. Two sets of parentheses here. 0.34 times parentheses 1 minus 0.34, close the parenthesis, divide by 50, and close the last parenthesis. What do we get? We get, well, our margin of error gets larger and larger. So this is approximately 0.17 or 17%. Very well. I calculated the margin of error. Now I go to the final step, find the confidence interval, which is p hat. P hat is 34%, 0.34 minus E. I calculated the margin of error to be 17%, comma, P hat, which is 34%, plus E, the margin of error, which is 17%. So my confidence interval approximately is 0.27, and let's see here, we get 51. What's the meaning of that? It means that I am 99% confident that the proportion of blue candies in the jar in between 27% to 51%. In this big jar, I am 99% confident that if I start counting these candies, between 27% to 51% are blue. Almost a third to a half. Half of the jar might be blue candies. Now, a better confidence interval using calculator. Always use your calculator to double check your confidence interval to make sure you have a correct confidence interval. But at the same time, you need to know all of these steps. On the exam, they might ask you, hey, find the margin of error, not the confidence interval. What is the margin of error? You need to know the formula. You need to punch in ZC, P hat, 1 minus P hat divided by N.
Wait, Professor, I have a question.
Fix this to 17, not 27. So let's go to the calculator. Here we go. So we're going to go to stat. Then we're going to go to tests. Well, now we need to find one proportion Z interval. One proportion Z interval. Very good. Let's click on that. X is going back to the beginning step. X, the number of blue candies, 17. N, the sample size, 50. The confidence level is now 99%. Let us do the calculation. What do we get? Well, we have 16.74% and 51.25%. So my confidence interval using technology is 0.1674 and 0.5126. Or the population proportion is in between 16.74% and 51.26%. I am 99% confident about the proportion of blue candies in the big jar. So what if I change the confidence level to 80%? What if I change this to 80%, to 85%? Suppose we want to calculate the confidence interval when it is 85%. So let us go to our calculator. Here we go to stat, we go to tests. We need to find two proportion, one proportion Z interval. Okay, 1750, now you have 0.85. Let us calculate. This is the confidence interval that you get. It is 0.2436 and 0.4364. So the population proportion is in between 24.36% to 43.64%. This is the proportion of blue candies in your population.